Good morning, everyone. I do have a blue shirt, but I'm not staff, so don't ask me questions. um, okay, so today, since we're going to be 3 days together talking about microservices and cloud native and so on, I wanted to give you a bit of a perspective into why are we here, like why are we doing that, right? And what is that? So let's get started. So, of course, let's start with a definition. What is cloud native? Is it a way for Amazon to get you buy more of their stuff and you liking it? Or is it more like the traditional software vendors to make you buy more stuff? Same model, different way to deploy things. Or maybe that's Microsoft who have the cake and eat it. They got a cloud, they got software, everything is fine for them. Or is it just a collective hallucination from our industry? Just because we like to change, just like the fashion industry, software is very much like that to some extent. Or is it all of the above? I think there is a strong case to be made around the fact that it's actually a bit of everything here. So let's take a step back and see why we're doing it despite the hype, right? So let me give you my definition of cloud native. Cloud native for me is not necessarily in the cloud, but it's on a platform that gives that have very strong opinion. The most important opinion of that platform is that I might kill your instance and restart it somewhere else, right? So you're not guaranteed that your instance will stay alive forever and ever, just like your bare metal hardware was, more or less able to do, right? So that's a big constraint. That's a big one to swallow. But once you're ready with that one, then you can have very interesting benefits from the cloud native platforms. The one that is sold is the infinite scalability, or at least from an application point of view, I ask for more and I get more, and I don't have to think about, oh yes, I need to deploy this, new physical hardware or this new VM manually and so on and so on. So that's a big one. You can even get auto scalability by listening to, the workload, the load on the resource and then adjust accordingly. The other one is instant access to resources, whether it be hard drive, databases, queues, everything that some people would call a middleware. You have instant access to that. That also means that to have access to those resources, you're not guaranteed into where they will land and where they will live. So your application will have to accept the fact that the resource might shift and move somewhere else, and you will have to think about those problems. That's cloud native, and related to cloud native, to me, are some strong words. Probably the strongest one is microservices. So cloud native and microservices for me go hand in hand, and I'll explain that in a minute. But also 12-factor app, or generally speaking, the new architecture style that we do embrace when we go for microservices. Container platform, whether they are actual containers or some different model, but the fact that a platform is orchestrating your load is an important aspect. And DevOps, because, hey, why not? So what does enable cloud native? To me, at the core of it is the application orchestration platform. The fact that you will describe how your application will be deployed as code, right? And then you will deploy that and have the platform do the deployment for you, and also scale the application for you based on some, input and the overall load. It will and margin capacity. It will, deploy more instances of your app to deal with the load or reduce the application. But more importantly, it's also managing the app. The fact that, hey, a node just went down. I recognize that. I'll deploy another one, maybe on the same actual, orchestration platform node or a different one, but I'll maintain the fact that your application stays up, and that's a big one. And what are cloud native providers? You could see different approaches, but at the core of it, again, is there is an orchestration platform, whether it be of container or not. Here I took Kubernetes as the example, but there is an orchestration platform that does offer what's in the middle, right? But that's not enough. You also need these higher level things that I was describing as far as resource capacity, like storage capacity, databases, queues, All of those are services, but don't think of them as, oh, that's services on Amazon or Google Cloud or Clever Cloud or whatever. These could be actually on a provider like that, or they could be handled by the platform that you've deployed in your own capacity, right? The key aspect is that somehow those are self-managed to as much as we can. And finally, so this orchestration platform, you can deploy it yourself in whatever data center you want, or you can go to your favorite actual cloud provider, which is another data center, more or less. The next challenge, I'm not sure there will be many talks about that, but it's the multi-cloud aspect, whether it be multi-zone or actual multi-clouds. And that's really the next frontier because it brings an additional layer of complexity and challenges. But these are important to avoid locking, to think about deploying in a specific region, to test some business aspects before deploying in a wider area. So these are important aspects that try and think about during this week. So why are we doing cloud native? First of all, what are we doing when we do cloud native? Well, we do see a shift of going from this one big monolith, and there is this notion of lift and shift, taking the monolith, putting it in the cloud, I'm done, right? All right, this is not really, you will not really get the benefit of cloud native. So we've seen people split their application into more tiny areas, that let's call them microservices, but it can go all the way down to functions. And there are differences in the way you do that. What's inside, ideally, is the same piece of code, except less of it, of course, because you focus on less of the business area. But this should be more or less the same piece of code. Communication-wise, it's very different. A monolith will talk to itself, really, right, inside the same process. When you talk about a microservice, it will have to talk to 1, 2, 3, 4, 5, 10 other microservices to actually handle the request that was requested. So the communication patterns are going to be vastly different. I don't even mention functions, which is like all the way to the extreme. And also scaling is different. I had one monolith, and the way to make it better is buying bigger hardware and make the process somewhat bigger, okay? If I go for microservices, there's been an optimization shift. Instead of requests per second, we shifted into let's crank as much instances as possible inside one box. Because the way you do scale an application in a microservice, assuming you embrace 12-factor applications and say stateless applications and so on, is that instead of saying I'm going to get that process and make it faster or bigger, I'm just going to deploy a new instance of it. So you literally start a new instance of your application to deal with the scalability aspect. So you need to shift your thinking from request per second to request per second per megabyte. Because you can literally deploy many instances of the same app. And what matters is that there is no lock or scalability problem down the line by the various services you're using down the line. Okay? Oh yeah, one more thing. Function is an interesting beast. To me, it's not vastly different from a microservice, except one thing. It stops, right? It scales down to 0, which means the platform, let's just simplify it, the thing that will take the request will look at the function and literally start it from scratch if it's not already hot loaded, right? Which means the startup time, the time to the first response from 0 is actually an important aspect. Okay, so why are we going through this pain of like splitting stuff into baby applications? Again, to me, that's enabled by the orchestration platform. The fact that we can describe how we want to deploy the application, ship that as code, and let the platform deal with that means that we don't have a massive complexity as far as deploying a software in production. Which means instead of mutualizing that complexity into one monolith, we can really say, let's create many microservices, and all of those deployment-wise will not cost me as much. It will be mostly automated. And that's an important aspect because then you're free to isolate things. And the reason you isolate things is that in case you make a mistake, it's all right to make a mistake, really. In case you make a mistake and say the app 3, the small part of my Uber application, if I made a mistake, technical, I went for this database and this architecture and it turned out to be a disaster, I can rewrite from scratch. It will cost me, but it will cost me a small portion of what the microservices would have cost me. In a microservices, essentially you you embrace the same technology across the whole microservice. You've got very strong adherence. If you split that in microservices and you properly isolate those microservices, you can entirely replace one stack with another without affecting the other microservices. So the cost is not that big. So it gives you agility to replace things. That's okay on the technical aspect. That's also okay on the business aspect. Hey, I need this new feature right away. Let's give it a try. And let's deliver it right away, right? So it gives you the ability to redeploy this one new features without affecting the rest, and therefore being able to release it much faster. And also give it a try as far as the feature. Let's deploy it to 5% of our customers and see how they react. That way, instead of deploying an entirely new monolith to try and do that, you can literally deploy a new version of your app 3, so app 3B, and then have a few percentage of your workload going there. So that's what it gives you. That's why essentially we're going for microservices in my view. There's also a small optimization aspect in the sense that if app 3 is really the most heavy usage CPU-wise, I can scale that up to, say 20 instances, while the rest is only down to 1 instance or 2 instances. So there's a bit of an optimization factor to that model. Okay, so we're going for that. We're going for microservices. What are the challenges? The first one is the speed of development. Remember, we can split stuff in microservices and we can scale and we can get, a 20 or even 50 microservices where we had one monolith. I don't know about your team size, but it doesn't go from 1 to 20x the same way. So it's the same 20 or maybe 30 people that were working on the monolith that will be working on the microservices. So the time they have per microservice is actually divided by 20 or 50 or, in case of functions, 200. So the time for extra ceremony, time to test, time to figure out how you wire one thing with another is going to cost you more and more. And I think there is a fundamental trend where people are choosing platforms that are much easier to use because they don't have time. They have, just by the nature of the architecture we're going through, they don't have time to work on and realize, how to optimize each of those microservices. So how do you try and help those developers to be more productive, right? It starts with how do I get a new member and get it on track and off right away. Some people go for IDs in the cloud so that the environment is standardized. You can think about many ways, but how do I get somebody consistently up to date and ready to deploy and run and work on a microservice? Also, how do I switch from the microservice I'm working on to the new one because there is a massive bug in production and swap and be immediately productive? That's another aspect. How do I go from the code to the code being ready to be deployed, right? Do I have to learn a new tech? How long it is to start, to test? What's the overall time of my test suite? All of that is taking time, and we have, a 20th of the time for each of those. So that's an aspect. And once you think, okay, the code is ready, let's go in production. How much have you automated in practice? Do you have continuous integration? Literally, do you commit and it goes in prod right away? Is there some manual process in between? Think about those. And think about those even after that. Like, how do you operate that system? Is it manual? Is there some sort of as a service or operator maintaining the stack for you, saying, hey, one instance is down, let's put it back up. Hey, this database is getting pretty full, let's raise an alarm to the operator, manual operator, or maybe increase the capacity, right? How much of that is automated so your team can focus on what matters, which is producing business values. The second challenge is application isolation. So we've seen the fact that cloud native provides you with good stuff, but it comes with this abstraction on the hardware and resource location you're targeting. So what you need to think about is, how do I make my app so that it doesn't have adherence to where it's deployed and how it's supposed to deploy it, and more focused on, what it's supposed to do, and then have all of those details being injected to it. So I really like the 12-factor app, not necessarily to adhere to the strictest of it, but to think about it from a design point of view and realize, okay, am I making my application okay to run in a cloud native fashion or not? And you see the services here, like how do I wire one app with another? So that's the service mesh and the observability and all of that. How do I expose my app to the outside and do throttling and stuff like that? That's the API gateway. How do I store states? That's all of the 4 here. State is important. That's going to be an important aspect of your cloud native app because you're going to put it outside the application. Cache, sharing actual state, not losing it. Database, messaging, etc., etc. You need to externalize the environment variables so they can be injected into your app and be dealt with by the orchestration platform that will kill you and restart you somewhere else. And the key aspect is going to be to define what's going as an input for my app and output of my app. It could be an HTTP endpoint. It could be a message, schema of sorts. The key thing is to try and put your application as stateless as possible and delegate the complexity to services, whether they are actual software you deploy that are operated or they are actual services in a more classical sense of Amazon or these guys. Okay? The other one is data isolation. So app isolation is actually easy. Data isolation is more challenging. So you got your apps, and they can be deployed independently from one another, so life is good, except, well, it's the same data, so I'm just pointing to the same database. And you have a distributed monolith, which is giving you all of the bad stuff about distributed system and all of the bad stuff about having a monolith. So don't do that. So and that's a bit of a challenge, but what you need to do is to really isolate your applications and the data as what I call an island of microservice. So that's the thing that is the unit of deployment. So I can literally change the database as well as the code if I need to rewrite application number 2 without affecting 1, 3, 4, 5. Okay, that's the key aspect. So each microservice has its own data store. But the data is going to be shared, right? A user is used in many different domains across the application. So how do I share that state? Maybe it's a one-time copy. Maybe it's a copy every 24 hours, and that's fine. And maybe that's a data stream, so I've got on-the-fly, update on my data. You need to think about those, and how do I have this river of data going from one microservice to another? So think about this during the week. Multi-cloud is an interesting aspect. I've got one client, and I want to be deployed in multiple clouds so that a user can go to one cloud or another. But maybe I do want some sort of a client affinity for a given zone, right? Maybe I want all of the clients closer to that data center to go there. Maybe it's just A to N goes there. And the key interesting aspect of that is that once the user reach one of the cloud, then you can do local operations and local communication between the microservices. You don't want to have to call one microservice, then go to another cloud and go back to a third cloud and back, because that will cost you a lot and it's going to be super slow. So you need somehow to have client affinity. But if one of the cloud goes down or you decide to kill it for, I don't know, you don't like your provider or something, how do your customer fall back to this other cloud? Well, they can, you just flip a switch into your load balancer, but you also need to ship the data. And probably shipping the data has to be done on the fly as soon as you change the data, instead of like, okay, I need to kill this cloud, let's move everything, because that's going to be too big, right? How do you do that? Maybe these are things like a Kafka cluster that synchronizes. Maybe that's a data grid that also synchronizes the data. So think about those problems as well when you try to go multi-cloud. Communication is a key aspect. We had very few nodes, so communications was maintained manually, and that was fine. But now we got 50x nodes at least, right? You cannot manually hope to maintain that communication by hand, right? You need that to be automated. And you need to anticipate that some communications will fail. Some microservices will not be there, or just the network, Can't rely on this thing. The other aspect is security. How do I secure end-to-end point communication, and how do I do that in an automated fashion? You have to have those questions answered. And the last one is almost more as it's an op but also a dev aspect, is how do I debug that thing? How do I know that something is wrong on the system so that I can zoom in? how do I know the path from one request all the way through, and how do I have a view of that to see where the problems are? Where is it too slow? Where is it dropping? You need some tracing, in your platform. The not last one, almost second to last one is resilience. Microservices are a mess. So you had one box that was handling everything. I know you got 50 boxes, and here we only see 6. But they will talk to one another just to answer one request, right? So if one of them fails, let's say you've got HTTP or RPC coupling. So the last one fails, and the failure is going to be propagated all the way up to your client in the end. So if you have a microservices to be more resilient, but just one of them failing means the whole thing fails, that's a problem. So you need to work around that. One of the options is circuit breakers. Circuit breakers are two things. One is they avoid to hit the demand down. So instead of keep kicking the microservices that is suffering down, you just stop sending requests and you deal with that at the client calling for that request. But it means you need to have business logic. What do I do if I don't have access to that information? So it also forces you to think about the business impact of having a degraded system if I don't get that information. There are other aspects to it. What does that mean, degraded? Sometimes it means I just cannot do it, so you're literally losing requests. That's a problem from a business point of view. That has some business impact. Also, your user is seeing a big whale, just like the good old Twitter times, and you refresh, and he refreshes, and if you have, let's say, a classic one request, one thread model, then your number of threads waiting on the client that hasn't failed yet will jack up, right? Which means your thread pooling is not going to be your average need, but probably the worst case need in case something fails at the behind it. So that's also somewhat complex to think about. The other one key aspect of a circuit breaker is that it doesn't know how heavy or busy the services down the lines are. There is no information in HTTP to say, hey, I'm fairly busy, but I'm warning you, I'm going to be busy, try to throttle it a bit. There is no information like that. There is no back pressure. And the final one is, okay, a circuit breaker is here to break potential communication between one service and another, But what if I want to send the same information to 5 services in parallel? And one of them fails, the other 4 succeed. Ooh, how do I deal with the replayability? Do I replay just the last one? Do I replay all of them? These are complex aspects. So you also have this problem of public subscribe. Message-driven is interesting in that model because non-blocking message-driven, that is, because you could simulate an actual blocking call by sending a message and waiting for the result of that message in another queue. That's what we see down the line. But also, by sending messages, you can then have more than one instance trying to answer that request. So you've got this scalability aspect. You've got a queue of message that needs to be processed for a given microservice. And 2, 3, 4, 5, 20, 200 instances can then be started to crank up the volume if it goes too big. Okay? The other one is resilience. Okay, one microservice is down. That's okay. I'm just putting my request in a queue. It's not lost. It's going to be processed as soon as it's back up. And remember, the orchestrator platform will detect that your last microservice is down and will try to restart it automatically if it's an intermittent failure, or warn you if there is something much more serious. It means somehow, and that compounded with the data problem, it means that you're moving from a data at rest where everything was in a database and you were just fetching the data from the database into a data in motion. So it could just be a call to retrieve information, but it could be a stream of changes of your data. So it's like literally the change that are happening to the data set that I'm shipping to somebody else. So that's a message stream. Maybe it needs to be replayable. And it also solved the publish-subscribe problem because you publish one message and you can get as many subscribers as you can. It does come with problems. I'm not saying it's the solution, the magic solution to everything, but that's a very interesting model because it provides you a resilient system. You have the elasticity, so you can scale up as needs. You got the resilience. If I go down, a node goes down, I don't stop the process. It's just one message that will be processed a bit later. And you really have a responsive system from a user point of view. Reactive systems, slightly different than reactive programming, but they go hand in hand. But think of your application as a system. That's the key aspect of microservices. It's not just one microservice handling everything. It's a sea of microservices that have to work together. And if one of them fails, it just should be not a problem. The last one is density. When you deploy from one monolith to 20 or 50 microservices, then each instance, if there is a fixed cost of the platform to deploy one app, it's going to be 50x that cost, right? So that could be very quickly a bit of a problem from a density point of view. You're okay to go cloud native, maybe not if it costs you 20x the deployment model. I don't know, who is doing Java here? Okay, so Java is at a bit of a disadvantage here because it's been designed, I won't go into the details, but it's been designed to be very good at the old style, one big process, lots of requests per second, which means it has an overhead memory-wise in particular. So when you deploy 50 Java microservices, it's a lot of memory. And we've seen some team moving to other platforms. Not that they do not like the Java ecosystem, they're familiar with it, they would love to stay on it, but they had to move because of the density problem. Remember, the way you scale is by having more instances, not by having a bigger instance. And I said traditional here because they are solutions. I'll be talking about one of them. I know Graham, I don't know if he's here there already, but we'll be talking about another today. So there are solutions to that problem, but that's also a problem you need to think about when you go for microservices. So these are the challenges: speed up development, app isolation, data isolation, communication, resilience, density. I'm sure there are more, but you're here in the 3 days to discover them and find solutions for them, whether it be at conferences, workshop, or hallway conversations. And thanks for the organizer. So you see them as microservices. Well, you probably don't see that, but that's an Antonio in the back here. All right, thank you very much. Have a great conference and see you there the next 3 days.